Hello viewers, and welcome once again. We are still under logic, Christ Almighty God's Algebra. Today we are going to treat Law of Double Negation. Law of Double Negation. Let us start. Law of Double Negation. Law of Double Negation. Not P is equal to P. So this is an example of law of double negation, in the sense that it is called law of double negation because of this not connected double not connected before P. That's why it's called law of double negation, which is equal to P. So whenever we have double negation before a term or before a statement, is same at that statement. So this is a law of double negation. Let us prove it. So proof. Suppose not P is equal to P. We assume that the statement is true and it's a hypothesis. That means not P is equal to P. So in saying that whenever not P and the left answer of the question is true, also P and the right answer of the question is also true. In the same vein, whenever P and the right answer of the question is false, also not P and the left answer of the question is also false. We say that the statement is logical equivalent. That means they are equal. The two sides of the question, they are equal. Since the two sides of the question they are equal, we are going to transform it to by conditional statement and still preserve truth. So if and only if not P, if and only if P is tautology, being justified by logical equivalent. Being justified by logical equivalent. We have now transformed this equation to biconditional statement and it still preserve tautology. In the sense that it still preserve truth, that is tautology. In the sense that whenever the left equivalent is true, also the right equivalent must also be true. Whenever the right equivalent is false, also the left equivalent must also be false. So if we evaluate this statement, there is no possibility of getting falsity. Always true. He said that it is tautology. That means it is truth. Being justified by logical equivalent. It is through logical equivalent that we transform this equation to biconditional statement. So if and only if not P implies P is tautology. Being justified by logical implication. Now we said that we have transformed this biconditional statement to conditional statement and it still preserve tautology. In the sense that whenever the antecedent is true, the consequent must also be true. So in this by this condition, if you let this statement, there no possible negative falsity, always truth. We say that it is tautology. Being justified by logical implication. That means it is through logical implication that we transform this conditional statement to this biconditional statement to conditional statement and it still preserve truth, tautology. See, this is true. Also, this also must also be true. If and only if not P is logical implication of P. Now we say that not P is logical implication of P. So we derive this not P by the principle of logical implication. That's how we derive this not P. In the sense that this not P implies P, that is a conditional statement, is tautology. Since that is tautology, we say that not P, the antecedent, is proper implication of P, the consequent. So if that is the case, it is certain that not P exists. And if it's certain that not P exists, we say that not P is logical implication of P, being justified by principle of logical implication. See, this is true. Also, this also must be true if and only if not P is equal to not P. That means not P is equal to itself. It is true that not P is equal to itself, in the sense that whenever not P are the right letters of equation is true, also not P are the right equation is also true. In the same vein, whenever not P are the letters of equation is false, also not P are the letters of equation is also false. We say that it is logical equivalent. The statement is logical equivalent. That means it is true that both sides of the equation they are equal. So it's being justified by identity and the sameness. Being justified by identity. Being justified by identity. So if and only if not P is equal to not P and bracket P and P or not P. Now we say if and only if not P is equal to not P and bracket P or not P. That means we add the right answer equation with P or not P, which is equivalent to T. And whenever tautology is and with enter set at that time, so tautology and with not P is equal to not P, which is set at the left side of the equation, so it's still equal. So we justify by law of identity. It's through law of identity that we AND P or not P with not P. We justify by law of identity. If and only if not P is equal to not P and P upon P. Now we have transformed this P or not P to, that means P or not P, that is the disjunctive statement, to P upon P, and P implies P, that means D to conditional statement, and is still equivalent to D. The two sides of the equation they are still equal. Instead that P implies P is tautology. Tautology and with n times sentiment is that time. That tautology and with not P is sentiment as not P, which is equivalent to the left side of the equation. So it's still equal, it's still law. So being justified by first edge case law. You see first edge case law that you should take this P or not P with P implies P, because they're logical equivalent. So being justified by first etiquette law. So if and only if not P is equal to not P upon P and the P. Now we have distributed this P, this implication P, to the fixed conjunct not P, and it's still logical, it's still law. In the sense that not P, which assumes to be P, so P upon P, and P implies P topology. Topology and with P is set as P. So P is still equal to not P, but the that not P is P. So the person that is that's still equal. So that's still law. So this not P, this P is being split to first conjunct not P by the split of implication. So it's being justified by the split of implication. Being justified by distribution of implication. If and only if not P not P or not P and the P. You see that we have now transformed, we have now revised this P, this conditional statement to justice statement. Why do we revise it to justice statement? Is because this P is being generated from the justice statement. So whenever I want to revise it, it's going to be also in the justice statement. That's why I revise it to justice statement. It becomes not P or not P. And it's still equal to P because we are sure that this is P. P or not P is equal to T. And when T is and with any percent for that term, so it's equal to P. And P is equal to not P. Not P is assumed to be P. So we say that being justified is two first case law that they transform this question statement to the disjunctive statement. So being justified by first case law. Being justified by first case law. So if and only if not P is equal to not bracket not P and the P and the P. You see that we have now substituted this not P or not P with not bracket not P and the P. This disjunctive statement has now been substituted with this not P or not P has now been substituted with not bracket not P and the P by De Morgan's law. So it's equivalent to this. This is equivalent to this. That was studied with that not P or not P with not P bracket not P and the P. So being justified by De Morgan's law, that's still the two percent side equation that are still equal. So being justified by De Morgan's law. Being justified by De Morgan's law. So if and only if not P is equal to not F and P. You have seen that we have not split this this not P and P with F by law of complement. No, not P and P is equal to F by law of complement, and they both have the equation that's still equal. So we just justify by law of complement. We just justify by law of complement. By law of complement. So if and only if not P is equal to, now the negation of F constant, negation of F constant is T. The negation of F constant is T. So we have T and the P, and that's still logical equivalent. The process of operation that's still equal. Being justify by negation of constants. Being justified by negation of constants. So if and only if not P is equal to, then when T is an intersection at that time, that means T and P is equal to P. Being justified by law of identity. Being justified by law of identity. We have now proved our hypothesis. That means our assumption has not been proved that it is true that not P is equal to P. So if they conclude, say thus not P is equal to P. We are going to prove the converse. So if you prove the converse by the principle of externality, we then establish that law of double negation, establish that not P is equal to P is law of double negation. So let us prove the converse. Say conversely, P is equal to not P. You see that this P at the right as equation here has now becomes P at the left as equation here. This not P at the left as equation here has now become not P at the right as equation here. You said that it is converse. So we're going to prove the converse. So we assume that the statement is true. Say suppose P is equal to not P. So we assume that P is equal to not P is true. Since it is true, we assume that it is true. It means that whenever P is true, not P is also true. Whenever not P is false, also P is also false. You say they are logical equivalent. That means they are equal to each other. Since we assume that they are equal to each other, we are going to transform it to biconditional statement and to still preserve truth. So if and only if P implies not P is tautology. Being justified by being justified by logical equivalent. So, sorry, if and only if is by Gaussian segment, sorry. So we have now transformed this P equal to not P to by Gaussian statement and it still preserves truth. Instead that whenever the left equivalent is true, also the right equivalent must also be true. Instead, then whenever the right equivalent is false, also the left equivalent must also be false. So if you break this statement, there are no possibility of getting falsity, always truth. You say that the statement is tautology. Being justified by logical equivalent. It is logical equivalent that will transform this equation to biconditional statement. So if and only if P implies not P is tautology. Being justified by logical implication. That means we have now transformed this biconditional statement to conditional statement and it still preserve tautology. Instead that whenever antecedent is true, the consequent must also be true. Since that is the case, we said that whenever I read this statement, there is no possibility of falsity, always truth. We said that the statement is tautology. Being justified by logical implication. It is through logical implication that we transform this biconditional statement to conditional statement. If and only if P is logical implication of not P. You have now derived that P is logical implication of not P by the principle of logical implication, we derive that P is logical implication of not P. In the sense that since P implies not P is tautology, that means the logical statement is tautology. We then say that P, that with the antecedent is proper implication of consequent not P. So since it is the case, you see it is certain that P exists. Since it's certain that P exists, you say that P is logical implication of not P. So if this is true, also this also must also be true. So if and only if P is equal to P, that means the line of relation is equal to itself. It says that whenever this P is true, this P is also true. When this P is false, this P is false. It says that they are logical equivalent. That means the both sides of the equation they are equal. Being justified by identity, that means the sameness. Being justified by identity. So if and only if P is equal to P or bracket P and not P. Bracket P and not P. We have now all these statements. This P has now been or with P and not P. That's equivalent to F. And when F is or with any time, that term. So P or F is equal to P, which is equivalent to the left hand side of the equation. So being justified by law of identity. Being justified by law of identity. Say if and only if P is equal to P or not bracket not P or P. We have now this statement has now been substituted with not bracket not P or P by the Morgan's law. They are still logical equivalent. So being justified by the Morgan's law. Being justified by the Morgan's law. So if and only if P is equal to not bracket not P and bracket not P or P. We see that we also substitute this statement. Statement has been substituted with not bracket not P and bracket not P or P, all in bracket, by the Morgan's law. We set it by the Morgan's law. We substitute that statement with the other one. So being justified by the Morgan's law. Because of this side, we say that if and only if P is equal to not bracket not P, sorry, if and only if, now you see that this not P and the bracket not P or P is equal to not P. This not P and bracket not P or P is equal to not P by law of absorption. So it's equal to not P. Being justified, that in this statement now, this not P and the bracket not P or P is being substituted with not P because they're also equivalent by law of absorption. Being justified by law of absorption. Sorry. If and only if P is equal to not P. Now you see that you have now gotten, you say that this not bracket not P is equal to not P by law of distribution. So you just distribute this not P to this P, this not combination to this not P. It becomes not P. So being justified by law of distribution. Now I have now proved that I have now proved our hypothesis. Our assumption has now been proved that P is equal to not P. I mean the converse has now been proved that P is equal to not P. Then we say thus P is equal to not P. Now having proved the converse, we then conclude say therefore by the principle of extensionality not P is equal to P is law of double negation. So therefore not P is equal to P is law of double negation. So we have now proved that law of double negation exists. So it is true that law of double negation exists. So at this juncture, we shall draw our curtain. Thank you, viewers.